Hello, everyone, and welcome to Digital Twins in Manufacturing with the PDM collection. My name is Juliana, and I work here in marketing at MicroCAD. And today's presenter is Jose Trillos, our applications specialist. At today's webinar, Jose will show the tools and methods available in the PDM collection to build, maintain, and make the most out of these models. Throughout the webinar, as usual, you can ask a question on the left-hand corner. You can ask Jose any questions. This is your time, and we want you to make the most of it. And in the upper left-hand corner, you will find links to our social media and website. Also, check our YouTube channel there. We post all of our webinars at the end, so you can share with colleagues or watch it on your own time. And without further ado, we'll pass it on to Jose. Hi, Jose.
Hi, Juliana. Thank you. I'm going to share my screen now. All right. Now sharing my screen. Can you see it?
Yep.
Thank you. Okay, welcome everyone to this webinar. Today we're going to be talking about digital twins, specifically in the manufacturing environment, and what are the tools that Autodesk offers to manage this digital twins solution. Actually, I would call that a solution rather than a problem, because it's actually something that's very useful, something that's on the mouth of everyone right now, not only in manufacturing, but also on the AEC collection in regards to BIM modeling with architecture, infrastructure, everything like that. So in today's webinar, we're going to be exploring the concept of digital twins, what they are, how they can help us, what are the benefits of having a digital twin, and how we can see a digital twin in the manufacturing business, what tools we have available in the product design and manufacturing collection from Autodesk to work with this. So what is a digital twin? Maybe you have heard the concept before, but maybe you're not very familiar with that, or maybe there are a lot of balls flying around about what is that, because you may think that it's just like a CAD representation of an object. And essentially, you can think of that of a digital twin like that. It's dynamic, it's an up-to-date representation of a physical object or a system. So that's the main point here. It's not just a representation of something physical, for example, a car or a building or something like that, but it can be a representation of something that's more intangible, something as a system, like a city, or all the systems that work inside of a building, or even if in a very small product such as a mobile phone, all the circuitry, the mechanical parts, electronic parts, all of that. So it's much more than just a digital representation of a certain geometry. You can think of it less as a traditional 3D model, but more as an information model. It's a common hub, repository of data, the data reference that it's created when you're creating your project, when you're developing your product, when you're thinking about your building or whatever it is that you're going to be working on. And it evolves. It's always attached to the asset's life cycle, from the design through the manufacturing, through the construction, all the way through the operation, maintenance, even when the product or whatever it is that you are working on, it's going to be decommissioned. All that information is being fed to the digital twin model. So it's basically like having everything that you have in the physical world, but in a digital world, and working with that information and with the digital tools to be able to predict and to be able to do so much more that you would do in real life. Okay. So if you think, for example, on the digital twin of this wind turbine, you may have the actual turbine that's working on real life, and you have a digital model that's always being fed. Its information is all been getting to that digital model. So unlike static data models, digital twins are actually like living entities that actually evolve in real time. They grow as their real twin grows. If the real twin is changed or suffers from something or gets damaged or needs maintenance, that it's fed also on the digital twin. They learn, they update, they communicate with their physical counterparts, and they use the latest tools in information technology to do that. So, if we were talking about construction business, we would talk about BIM models to feed these digital twins. We are talking about artificial intelligence. We are talking about machine learning, Internet of Things. All those tools that are available to us now are the ones that are used to feed the digital twin. So basically, the digital twin can be used for all of the stages of developing whatever it is that we are creating, for the planning, for designing, for the construction of the asset, for running the operations and running the maintenance. All of that can be used the digital twin for. So, for example, if you are creating a digital twin for this wind turbine, you may have the CAD model, you know, and you can plan on building your turbine with the CAD model. But once it's designed, once it's built, you can feed the digital twin again with everything that happened in real life, so you can plan for something else. You can add sensors to the turbine to be able to know when we need to run some maintenance, and the digital twin will alert us of that. The digital twin may learn from what's happening on the real turbine and use analysis tools, use project management tools, all those kind of things. Okay, so a digital twin can take many forms. You would think of that always as kind of like a 3D CAD model, but it has many, many, many more information than that. Okay, so you can have digital twin of whatever you want: a car, a building, an element, a bridge, a factory, a complex ecosystem such as a rail, road network, even a city or a smart grid, or for electrical transmissions, all those kind of things. So when we're talking about digital twins, there are actually 5 levels in which we can think of those. So we got a descriptive twin, which is basically like the starting phase in which we would create a digital replica of whatever it is that exists in real life. Okay, so here is where you would find most of what is used actually in well, in the manufacturing business or in construction business. It's just a description of whatever it's included in real life, and maybe it's used for documentation. It's just for inputting and extracting data. So um, aside from that, well, it's very useful, but there's so much more that can be done with a digital twin. Okay, you can get an informative twin that it has a added layer of operational data and sensory data. Okay, so whatever information you're giving to the digital twin captures and it adds added value to that data. It verifies data, it analyzes data, it makes sure that we don't have maybe like different silos of information. Everything is centralized, and the data is always being checked to make sure that everyone is working on the same level. Okay, so here you may find many PDM tools or those kind of tools like Vault, Opchain, all those kind of things. Okay, you can go a step further and have a predictive twin. So this twin uses the operational data to gain insights. So whatever information you're using, you're just not checking if it's there and you're letting people know, but it's actually being used to analyze and to make recommendations on how the asset should work in real life. So, for example, if a car is analyzing the oil levels in your motor, well, it can tell you when your car needs an oil change. So that would be like a very basic example, something that we actually have seen and it's pretty common. But now imagine that something like that could be implemented for whatever it is that you're doing. Okay, so in your building, you can get sensors that let you know if the building is being, uh, if it has structural damage, for example, or thing, for example, on autonomous cars right now that are able to read inputs from their environment and make decisions as well. They can stop, they can apply brakes, or they can let the user know that something's going to happen, all those kind of things. We're talking analysis here with the predictive twin. We can add another layer to that to get a comprehensive twin. So in this stage, you may find models that are also used for future developments. Okay, so you start to simulate stuff that doesn't actually exist in real life. So we're considering here what if scenarios. Okay, so what if the building that I have right now was submitted to an earthquake? Okay, you can always plan for an earthquake if you're creating a building and design everything for that, but it's a different thing to gather all the information that you have of your building as it is right now and try to simulate and predict what's going to happen in a case of a future event. It's a completely different thing. Okay. So that's very advanced stuff, and that adds a complexity layer to what a digital twin can do as well. And the latest thing that we would like to get to in the future, this is actually doesn't exist right now, but it's what we're headed to, is what would be like an autonomous twin. So the twin, in this case, would have the ability to learn and act on behalf of the user. So there are some functions that allow you to do stuff like that, such as um, autonomous cars, those kind of things. But there, you always need human interaction there to be able to make the proper decisions, you know. And eventually, what we will try to accomplish is to have this digital twin make those decisions to, so people just give the inputs and make sure to have control over how these autonomous twins work, but the actual work would be done by these twins as well. All right. So now we have seen what a digital twin is. Now we can start to look of in the benefits of a digital twin. Okay. So in any business that we were talking about, manufacturing or construction, media, entertainment, all those kind of any business, there are several benefits that are common for all of them. You can have optimized performance by using simulations, by using insights with all the data that you've been using. That helps you to make better decisions and optimize performance. You can also have a full view of all the data related to the project, so you eliminate data silos and unlock value across a project's lifecycle with all the historical data and real-time data in one place that it's checked, that everyone knows that it's reliable. Uh, you can also have smart predictions with real-time sensoring data, not just like physical sensors, but digital sensors as well on software, on the data that you're managing as well. and you can get predictive recommendations on probably future or future scenarios that may exist on your project as well. So that can help to make smarter decisions, smarter predictions as well. And with all the management tools and all the digital tools that you can get with digital twins, you can get faster results for tasks that would take longer to accomplish before. Okay. Now, if we're talking about the type of persona that's going to benefit from the digital twin, depends on the type of persona. So, if we're talking about owners, well, um, as owners are usually involved in money, you always get a better return on investment as well. There are the tools are out there, and what we have seen is that in many occasions people actually don't use them. They have them available, but they don't use them, and that's something that happens too in the PDM collection. You get all these tools that can be used to implement digital twins, to implement PDM, and sometimes people don't realize that they already have them. Okay, so you can get a lot of value for what you already have, and you can get greater return on investment as well. For managers, you can get smooth operations, you can get quicker maintenance, you can get more reliable data to be able to accomplish all the tasks or their actual job. Okay, you can you don't have to struggle with confusing data, with missing documentation, all those kind of things as well. For business environment, that is for the actual firms, you see as the firm as a persona, like the organization. All of these benefits are translated into more value. It's translated into more business. They win more projects. They can offer more services. And lastly, for all, well, this results into long-term value as well. Now, if we're going to talk about digital twins on the manufacturing environment, we can get some of the we can get the benefits that we mentioned before, but we can get additional benefits because specifically for manufacturing, the digital twins have been around for longer than on construction environment. I mean, if you look at BIM modeling, all those kind of things, it's relatively recent from the last decade, I think. But digital twins for manufacturing have been used even from the 60s. NASA was the first agency to produce a digital replica of the rockets to be able to study possible scenarios where something might go wrong with the mission, stuff like that. And when product life cycle management on all of those tools for manufacturing first came up, digital twins were something that naturally had to come with it. So you would be able to not to have a 3D model of whatever you're building, but to have more and more information into that model so you can make better informed decisions as well. So why wouldn't you need that? For manufacturers, the data that's collected for digital twin actually gives you a greater insight into what the life cycle of the product is. It lets you see or predict how your product is going to live, how it's going to be able to develop, how it's going to be born from an idea, from a drawing in a napkin, into a detailed 2D plane, into a 3D model, into a bill of materials, into a manufacturing plan. You can see all of that with the insight that the digital twin gives you as well. It gives you the tools to optimize your workflows, to manage your supply chain as well, and to be able to check for quality issues in an earlier stage and in a later stage of your project as well. So it has many, many benefits as well. in manufacturing. It can it can improve your operational awareness of the process to better estimate current predicaments, to better predict future situations, future problems. Uh, Having all your data in a digital twin creates a single repository of the information that it's being checked, that you can make sure that everyone is going to be looking into. So it can break down data silos for workers, especially with today's world where everything's very globalized. There are people working in in the US, in Latin America, Europe, Asia, whatever it is, in the Arctic, the moon, whatever it is you're working, you can always connect and get the actual up-to-date information. A digital twin lets you do that. You can streamline your process with automation to accelerate product development, to automate tasks, and to get shorter response times. So that gives you to a competitive advantage. It connects the entire workplace, it connects the supply chain, the customer base. All that information is streamlined, so you get shorter lead times, you get less flaws, you get less requests for quality issues, all those kind of things. So that's translated into competitive advantage. So when we're talking about the solutions that exist for creating and maintaining digital twins in manufacturing, we need to be looking into three main components. We need to be talking about the digital transformation that needs to occur, that is creating the 3D models and gathering the information that we actually need for creating the digital twin in manufacturing. We need to be able to manage the life cycle of the product. So we need a life cycle management software as well. And we need to be able to connect the data with many stakeholders in our company. So you can see that as a cloud solution. If that's the easiest way to do that, but it doesn't need to be cloud. Actually, probably there are regulatory issues that you need to follow, stuff like that, that don't allow you to use cloud solutions. So maybe you just need something to connect or to send information that's not just like an email or some guy running around with a USB stick, stuff like that. But you need to be able to connect your data as well. And doing so, you can achieve convergence of the information. Okay, you can have a single point where everyone will be looking for that information. You will be able to collaborate so that data um, will be used for all the development of the product as well. And it will be able to produce automation of all the tasks as well. Okay. So, what are some of the solutions that are existing in Autodesk for getting a digital twin, for producing a digital twin? If we're talking about the digitalization, we're talking about creating models, we get tools such as Inventor, we get tools as AutoCAD, as Recap, or gathering the information, the actual data, physical data, geometry, all of that to be able to start with a digital twin. And in manufacturing, it's a little bit easier to see because you're always thinking of an object. Okay, if you're talking about AC, probably it's a little harder to see because you would think of a digital twin and you would think of a model of the building, but there's much more information involved in that. In the manufacturing business, sometimes you just are thinking of the 3D model, and that's it. But you need to think on all the information that you need to manage for that as well. So for creating the digital versions, you can use tools such as Inventor. You can use tools such as AutoCAD, factory design. You can use analytics tools like Nestron, like Autodesk CFD, all those kind of tools that are part of the manufacturing collection as well. Uh, there, are, there are tools that are kind of hybrid too, such as Fusion, for example, that are designed so you don't have to jump from software, program to program, but try to accomplish all of this in a single environment. So for example, Fusion 360 lets you make this digitalization as well, and lets you manage all that information on the cloud. So it's a cloud solution. Well, online. Let's put it that way better. Because you actually have another cloud solution without Desk 2, that's Autodesk Drive, where you can manage all of the data and you can control very precisely on who are you sending the data to, who will be able to download it, to see it, to make revisions, to edit, everything like that. Okay. Now, if we're talking about the lifecycle management, there are tools such as Vault. If you're not going to be using the cloud. So this is why it's kind of on the left. That lets you manage all of your data and have all the requirements for creating a digital twin, such as having all your information in a single platform, in a single location, do revision controls, all those kind of things. And if you're talking in cloud solutions, you get Option as well. So it lets you create projects, it lets you manage projects as well. It lets you create items that will work as a digital twin that will have many information associated with your physical model. We also have a recording on how Option works in case you're interested here at MicroCAD. You can attach all the information you want, emails, documents, PDFs, drawings, CAD models, anything you want to Option as well. And to gather and to be able to manage all of that in case the, the single software solutions aren't working for you, you got the Autodesk platform services. So this is what was formerly known as Forge. So if you have heard before about Forge, now this is called platform services. And this is a cloud developed platform. This is a set of web service APIs that you can use, you can build, you can download, you can purchase solutions, you can create new applications to be able to use all of these tools in the way that you want to. So we're talking about programming here. We're talking about implementing APIs and implementing these tools into what you actually need into your web page, into your software tools. Basically, just giving you the tools to be able to customize your software solution to the way that you actually want. Okay. So the future for us will be not only talk about all of these particular solutions, not only talk about Inventor, not only talk about Vault or just Option, but how all of this can be merged together, how we can use platform services from now on to be able to produce more competitive solutions, to get a better ROI from what we're purchasing when we get the product design and manufacturing collection. So I don't know if we have any questions, Juliana.
Thank you, Jose, for that wonderful presentation. And as a reminder for everyone, if you want to learn any of these topics in detail, you can always take a custom training with Jose or someone else on our team. We also offer group classes online. So if I don't see any further questions, Just wanted to remind you to check the MicroCAD website for future webinars. We have coming up next on September 21st, Design, Build, Succeed. Six strategies to complete projects on time and on budget. And then we have on September 28th, Sustainable Design and Analysis using Autodesk ACC Solutions. So yeah, thank you so much everyone for attending, and thank you, Jose, for that presentation. It was great.
Thank you, Juliana. Thank you, everyone, for attending, and I'll see you next time.
Thank you. Bye bye.